Hi! Today we'll speak about population statistics. And by saying population, we refer to a total set of observations that can be made. For example, if we want to calculate average height of teenagers, the population set would be the whole teenagers from all around the world. Or, for example, if we want to calculate average age of Birkbeck students, the population set would be all students at Birkbeck. We denote population statistics by Greek letters, and they are called parameters. So when we are measuring population statistics, we use Greek letters. So here are the parameters. Well, mean is denoted as Greek letter mu, variance is sigma squared, standard deviation is sigma, covariance is sigma of x and y, or whatever you are measuring, and correlation is Greek letter rho. Here are the explanations and formulas of parameters. So mean is expected value. It is often denoted as E of x, and it is equal to total sum of probabilities times x values. The variance is the average of squared deviations, and it is equal to total sum of probabilities times x values minus mean squared. Standard deviation is simply square root of variance, but bear in mind that you cannot calculate the standard deviation without calculating the variance, as the total sum of deviations is always equal to 0. The covariance is average of the product of the deviations of x and y, or whatever you are measuring, and it is equal to total sum of probabilities times x values minus mean of x times y values minus mean of y. And finally, correlation of x and y is equal to covariance of x and y divided by standard deviation of x times standard deviation of y. Now we can go through an example. Let's say we have share A and share B. Here we draw a joint probability distribution table of growth values of share A and share B, and in addition we wrote down marginal probabilities for each share A and share B, so we can calculate the averages. So the average of share A, which is mu of A, is equal to 1.6, and mean of share B is 2.4, and calculations are shown here. So now we can calculate the variance of share A and share B. So the variance of share A, which is the average of the squared deviations, is equal to 25.84, and standard deviation of share A is equal to 5.08. The variance of share B is equal to 10.44, and the standard deviation of share B is equal to 3.23, and all calculations are shown here. Now, there are two ways to calculate the covariance of share A and share B. One way is to apply the full formula, and you'll end up with this lengthy equation as shown here in red, or you can write deviations table. That is, you write down the joint probability distribution table, and instead of writing the actual values of growth, you write down the deviations as shown here, and then you'll shorten your equation to this, and this gives you the same answer as with the lengthy equation of minus 9.412. That is the covariance of share A and share B. Finally, we can calculate the correlation between share A and share B, and it is equal to minus 9.412 divided by 5.08 times 3.23, and it is equal to minus 0.57. Please note that the correlation can only take values between minus 1 and 1, and when correlation is equal to minus 1, it is perfect negative correlation. That is, when one variable goes up, the other will go down, and vice versa. When correlation is equal to 0, that means there is no correlation at all. That is, when one variable goes up, the other can go in any direction. And finally, when the correlation is equal to 1, there is a perfect positive correlation. That is, when one goes up, the other will go up as well, or when one goes down, the other will go down as well. In addition, we would like to show you how to calculate parameters by bypassing deviations. So instead of using the original formula for variance of the average of the squared deviations, we can obtain the same answer by subtracting squared means from mean squared. So let's say we have a simple example of x that can only take values of 3, 5, and 7, and here are respective probabilities. So to calculate the mean squared, that is expected value of squared x values, and it is equal to total sum of probabilities times squared x values, it is equal to 28.2 in our example. And squared means is the expected value squared, and it is equal to the total sum of probabilities times x values, everything squared, and in our example it is equal to 25. So to obtain the variance of x, we can subtract squared means from mean squared, and it is equal to 3.2. If you have any questions, leave them in the comment section. We'll try to answer them all. Thank you for watching. Bye!